plenty. I need to play recorder. Carthen! You're doing slides! Yes, you are.
No, Karthik, over here.
Someone needs to use slides. So this week we are doing gears. What are gears? What do you think?
They're usually like something that spins other stuff.
Yes, that is part of the definition.
Gears are what something rotates, which makes another thing rotate.
Someone to hit.
Gears make them. Gears help them make other things power off.
Someone to hit, but you have different meaning. Gears are like machines. And if you spin it with your hand, it will work.
Not all of them.
So yeah, so all of these definitions apply to gears. Now, let's get more through our definition. Gears are powerful that can be used with any machine, not just a manual crane, because you said. Okay, you can use this with an electrical motor, a manual crane, a wind turbine, generator, anything that might be used. You can use them to transfer one form of energy to another form of energy. For example, the dynamo torch. This is not a good example, but if you look inside, this is clear plastic, you'll see these gears. I'll bring this up later, but you see, the gears are providing electricity. The gears are providing electricity through this generator here, which allows the light to light up.
So manually, Kriti, I would like to add a point. So manually you will not be able to, even if you are a superhuman, you will not be able to spin it at that speed to generate that electricity to light up an LED. Okay, so you need to have an additional setup to increase your speed. Like if you do one rotation, you want to magically turn that one rotation into 40 times, 30 times greater. That's here in this case. Kriti, how many times you have increased the speed of one rotation?
This gear rotates one time. I counted the teeth on the gear and using some techniques which we may encounter later on, I discovered that the last gear, the small one right here, which is connected to the generator, is going 31 times the
36.
speed of the first one, connected to the crane.
So 36
now-
times. So manually, with the help of the gears, you have increased the speed to 36 times. Okay?
So the electricity needed to provide the light that is made by the LED 36 times the speed I'm cranking this. We'll go more into that later. So gears are commonly used in machinery, but they can be used in other things. For example, in the automator, we use something similar to gears, but that aren't gears. They turn and create a gear transfer. Simple. I believe your definition. What's your name?
Richard?
And okay. Well, your definition is they can turn something out. But here's something you may not know, but you might. An odd number of gears will make whatever turn the way the motor is turning. An even number will make it turn the opposite way the motor is turning. For example, if the motor is turning, say, counterclockwise, an even number of gears will make the final gear in your gear train turn clockwise. You can use an axle if you want to. Next slide, please. I just went. So, some terminology to know. Speed. What is speed not in gear? Okay, no answer. Well, for gear, speed is simply the number of rotations of a drive shaft of the gear. Torque is the sense which you rotate it with. And now we have some images to explain the next 5 terms.
Okay, Kriti, take a second. So in the previous slide, he was talking about odd number of gears will rotate in the same direction and even number of gears will rotate in different direction. Did you understand what he meant by that? So here, if your green is rotating clockwise, which direction do you think the red will rotate? In the first picture, in gearing down.
If it counterclockwise, it would go counterclockwise. Because it's following the direction.
Now, if you are rotating one gear in this direction, the next gear will rotate in opposite direction.
Yeah.
So, but if you put a gear next to it, then this direction 1 and 3 will rotate in the same direction, and 2 and 4 will rotate in the same direction. A gear next to it will rotate in opposite direction. So usually, if you rotate this, and this will make this rotate in the opposite direction. That's what he meant by odd number of gears, same direction. So gearing down. So speed. Kriti, show that again. So here, that's what speed means, right? Kriti, can you do the demo again? So give it to me. 1 second. Kriti, come here. Show it closer. So here, all he is doing is he's doing the crank, right? See a big gear. The big gear has 60 feet. The small gear, it has 10 feet. How many rotations are going to happen? For one big rotation of this, how many times the smaller gear would have rotated?
36 times. I mean 10 times.
60 by 6, yes, 10 times. And then since that gear axle is connected to a bigger gear, right? So if this rotates 10 times, this is also going to rotate 10 times because the axle. Okay, but if this rotates 10 times, this will rotate 60 times because this is a driver gear, this is a follower gear. Okay? If you rotate this one this side, Varun, focus. If you are rotating this clockwise, this will be rotating counterclockwise. So since this is connected, and then you have another smaller gear here. So for one rotation of this multiplied by 6, and then 6 multiplied by 6, 36. For one rotation, you make this, speed it up 36 times. Can you imagine, like you're doing only one rotation, but then somehow the energy which is reaching this motor is multiplied by 36 times. How are you achieving it? It's through gear. Because manually you cannot, by any means, you cannot make this motor LED light up. Okay, maybe if you use a hair dryer or something like that, but manually you cannot make this LED light up because it's humanly impossible to make that motor rotate at that speed.
So you're making it going clockwise, right? What happens if you make it go counterclockwise?
LED is one direction. I should have connected another LED with the anode connected to the negative, so then you connect. The rotation is going to be same. The math is same. Okay, just because of the LED property, it doesn't. No, do it faster.
Okay, so while the light is going around,
Okay.
we will go more into.
Okay, let them try for 2 seconds. Kriti, wait.
No, while it's going around, let's go more into the terminology.
So, what do you think the terminology is? Yeah, Kriti.
So we've been gearing up. Our next two terms are gearing up and gearing down. We're going to be determine the speed and the torque. So, as you can see in my image, if you gear up, you increase speed, but you decrease the torque.
So, which part is gearing up and gearing down in that? In that device, you have both gearing up as well as gearing down. Can you explain which one is gearing up and which one is gearing down?
Actually, there's only gearing up.
No, you have both. So when a bigger gear drives a smaller gear, you increase the speed. Okay, that is gearing up. If you use a smaller gear to reduce the effort to drive a bigger gear, that is gearing down. Okay, are you done, buddy? Kriti.
So gearing up and gearing down. I have got to. So gearing up and gearing up is where you drive a small gear with a large gear. You would increase these what? What do you think you would increase?
The number of teeth?
No.
We know the
Which way do you think you would increase? The speed or the torque if you drive a small gear with a large gear?
speed.
Speed, correct. That you would increase the speed and how fast it goes. It's the ratio. For example, the LED. Where's the LED? Can I have the LED? For example, in this LED, seems to have lost connection and it wouldn't run out of charge. But here's how I determined that the last gear would go 36 times faster than the first. So it would rotate. The last gear would rotate 36 times.
One second.
And
I think we
one
can make
rotation
this
first.
rotate the other side, like instead of an arc 4 and so forth. If I switch this, I can do the reverse direction and then it should be able to, I don't know.
The LED is already out of magnetism.
Sorry, what?
No, don't worry about it.
Okay, you continue, Kriti, and let me try to fix this.
So in our flashlight.
So earlier I was rotating clockwise, right? Since I changed, remember the motor class, magnetism class I took?
Yes.
So now I switched the blue with the black, blue with the red one. So now if I rotate it this side, the LED lights up. Remember, LED lights up in only one direction. So, yeah. In regular motor, you will not be able to do because you cannot change the poles. But since this is the tricky thing.
Anyway, so in our light there, I counted the number of teeth on the first one. If you inspect it closely, there was a small gear attached to a larger gear. This small gear had 10 teeth compared to the 60 teeth of the first gear. So now it's rotating 6 times faster. Then we have a large gear connected to the other gear, to the other small gear, so it rotates. And then there's a small gear to connect it to the second large gear, and that small gear is the last gear. The small gear has 10 teeth as well, and the large gear has 60 teeth, so it rotates 6 times faster than the other one. So the large one is rotating 6 times faster. 6 times 6 equals 36. And that's how I determined it would rotate 36 times with one rotation. And anyway, so that is a perfect example of gearing up because both gears drove a small gear with a large gear. So that's a perfect example of gearing up. And now I have a good example of gearing down.
Kriti, put it on the table. If you hold it in hand, you will break it.
Sorry. Not the Ferris wheel. This one isn't working, but if you look,
Okay, push it.
but if you look from this,
Okay.
I'm trying to. Here's better.
Take the crank from the other one.
So this is.
Take the crank from the other one. So here, if you use the same gear with the 18th with the 18th, then it will be super fast. Nobody will be climbing up in this ride, okay? So it goes super fast. So what do? You have a small gear, right? And then you have a big gear. So what happens? You are slowing it down.
Because of the weight.
Yeah. Yes. What are you doing? Do you have any doubts about this one? No.
Okay, so if you look at it from this one is going slower than the Ferris wheel.
Hold on to it.
Same.
Okay.
It's all like
Karthik, can you help him how to make this work? What did you do?
he broke.
Let me see.
Let me see.
Now, use the crank.
One of the classes we knocked on the table.
So sorry for the interruption, but you notice that this ride is going a lot slower than the Ferris wheel. Why is that? Well, if you look at it from the side, you see there's 42 something. Is that that?
Yeah.
So, okay. Next slide, please. Okay, so now we have a few different gears. We have a bicycle, which has some gears, and this is the driver gear, and this is the follower gear. Why do they rotate the same way? Because the chain acts as an idler gear. Understood?
Yeah.
So that's basically the way a bicycle works. And then we have that, which I don't know what that is. Next slide, please.
Wait, Kriti. So bicycle is a good example of gearing down and gearing up. Okay. So earlier forms of bicycle, if you see, they call it as penny farthing. Like they have a huge wheel connected to a small wheel, so that the guy takes time to pedal, but then the smaller wheel will be super fast, so that it pushes faster. And then they changed it to same size, so that the speed and torque is balanced. And then they came up with this where you have the gear, you are actually pedaling, but that's not the actual riding wheel. And then you connect that pedaling gear to that rotating gear, just like in the gear, right? The small gear is in the same axle as the bigger gear. So your actual wheel is connected to the smaller gear. Have you seen the bicycle? Have you noticed the bicycle? Right? You are pedaling here, but the